This entire concept was given to me by someone within my network. And I think it's important to start here, kind of like at the top, and explain these things on a high level before we dive specifically into the notebooks and the paper. So, first of all, let's talk about matrix arrays, because this is like the most important part of this, right? Let me zoom this up. So, this is a matrix array, right? This is a neural network, basically. The difference would be like we use like pretty much the only difference between this and like a typical neural network would be you have more layers, and then of course you're talking about let's say like a billion parameters, right? So this goes out to like a billion numbers, and then each one of these we use regularization. So instead of like 111, 121, 131, we use regularization so they'd be between a number between 0 and 1. So it'd be like 0.111. 0.1, 0.2, 0.1, 0.1, 0.3, 0.1, 0.1, 0.4, 0.1, etc. Right? And you go down, and the numbers are just like this, like except for they're normalized, right? So just add a point into each one of these. So 0.1, 0.1, 0.2, 0.1, 0.1, 0.3, and etc. You go back in rows, right? You would think that when it comes to like neural networks and like setting up a neural network and all of that, that we do something like more complex when we initialize a neural network than this, right? Like this is, I mean, like it seems like pretty basic math, right? Like it's not that complex. If you think it's more complex than this, you're adding more complexity to the equation than there is. This is a neural network, and we don't, at this moment in time, like for the most part, we don't adjust these numbers, like these weights, and we just initialize them all the same, all connected, all randomly initialized, right? And then our assumption is, I don't know why, but our assumption is that these are all the same, right? It's all like it's just like so you train it on a data set, and then it's gonna like update all of the weights like 100%. Like every weight will be updated the same, right? And it will have all of the same impact on each one of these individual weights. But what we find more and more recently is that's not the case. So this is the notebook that was given to me by someone within my network. And then so at the top here, they link the research paper that brought them to this, right? Which is the Superweight and large language models, which is this paper here. It's put out by University of Notre Dame as well as Apple, and it's published on November 11th, 2024. I remember when this paper came out because this is right around my birthday. But so this paper is interesting, right? And I remember now the interesting thing about this paper and how it was built, right? How this paper is built is that they were able to isolate one singular parameter within Llama, and then they removed and that one singular parameter and like obliterated Llama's outputs, basically, right? And then that's what they're able to find. And so they go through this, and they're essentially able to find superweights. And then in this, they find that there's good and bad superweights, but that by removing just a few number of weights, they can like essentially like destroy the outputs of this model. Is like really like what this research they go into with this research, right? And that's the kind of like the extent of this research paper, which is why I don't think it made it far a lot. But so with this, right, and then so it's interesting too because I want to highlight this as well. So you within AI and neural networks, you have two problems, right? One is this, which people think it's more complicated than it is. So they like overcomplicate it, and then once you stop overcomplicating it, the second problem is that it's a very wide and broad field, right? It encompasses a lot of different research areas and a lot of different aspects. This is dealing specifically with model weights in a very unique way. In my network, let's say I have, I don't know, I have literally a few thousand people connected to AI on all different levels, right? Like I could reach out to any company basically and say that's my network, right? Within that network, there's like 5 to 10 people tops that I know definitively would know in depth about this particular subject, like that they would be like all about this. There'd be like a few hundred or maybe 1,000 that would be fascinated by this, but this isn't their area of research, right? Like, and it'd be far removed from their area of research and their area of knowledge. So you have the broad knowledge needed, and then also too, once you overcome that, generally speaking, most of the people that overcome that broad knowledge base have a specialized knowledge base, and you get into here, and then so upfront, why aren't these things moving as fast? It's that, and then the third reason is we don't like these things don't move fast unless it's shared and encouraged around, right? So this came to me from someone within my network, which came from this original research paper here. So this is like three, like we'll call it generations removed from this research paper, right? And then so if this was all just Apple research and developed in Apple, we would have the research paper now. We wouldn't have this, and we wouldn't have my research on top, right? So it's all of these things. It's a collaborative effort. And then so why do I make these videos, and why am I making this video? Very specifically for these types of things. So let's dive into this superweights concept, because superweights is fascinating, and I've been avoiding the subject itself long enough. So superweights is very straightforward, right? In this research paper and this kind of research, this method is beautiful, right? They give you everything that you need here. So they're initializing a model, setting up the hugging weight tokens, and then what they go through. It took me a long time to dissect their experiments, right? So they're using the DeepSeek model, and they're using DeepSeek, the distilled Quinn version of the model, and then they're finding weights within the model, right? And then they're finding essentially potential superweights, and they're going layer by layer in the model, and then they're identifying these superweight super activations essentially within the model, right? Like models that have higher values, like, and you can see here, like, extremely exploded values, right? Like this one is, if this were the, like, going back to the paper, this would be the weight that we would probably obliterate this model, right? Would be pruning this, and then so that's what he tests next, right? Like so, he inserts a prompt. What is supergravity? And then essentially does that test and goes through and obliterates one at a time some of these weights, and then it's extraordinary, right? So, what is quantum gravity? And then so this is with obliterated weights, right? So, what is quantum gravity? What are the key points of its mathematical structure? What are the key points of 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 the key destroyed? It's just with one of like literally one of these superweights destroys this output, right? And then you prune out that one superweight. What is quantum gravity? What are the necessary conditions for its existence? I'm a student trying to understand quantum gravity. I have a basic knowledge of quantum mechanics and general relativity, but I don't know much about more advanced topics like quantum gravity. I need to figure out what quantum gravity is and what I need to understand to know whether it exists or not. I know that I need to start with general relativity because etc. Right? This is the same exact model, the same exact weights, just with the literally one neuron, one parameter obliterated. That's it. And this massive changes, right? And so you can go through and they have several examples of this, where it's just you obliterate one of these tokens, and it's massive changes on the model, right? And the key thing and the important thing to realize and to recognize within this is they do a good example here. These superweights, these outlier weights, they're both good and bad, right? So that's the key point to recognize. Like, it's not just like, oh, you remove these and then you get a good model, because you remove these and like you could blow up the model. Some of these are good, right? And then so he goes through and then does further analysis, and so within layer 0, here's the top. Essentially, each layer he finds the top superweights layer by layer, right? And then goes through, and then kind of gets like you can see like what these are doing, right? So original behavior, it gets stuck in a repetitive loop of key points. When you prune out that one superweight, it shows improved coherence, asks follow-up questions naturally, and the weight might be interfering with response completion coherence. And then you can see here, right? So the next one, original structured self-reflection, attempts to organize thoughts. When you prune it out, you get more direct explanation with a better flow. So this weight might seem to influence metacognitive processes and self-reflection. Next one, this weight affects question generation, but doesn't control repetition. This weight might influence question expansion exploration. So you can see these weights are they're tied to like different components, and they're doing different things throughout the testing, right? I mean, this is amazing testing, right? So this notebook, it's given to me at this point, right? This is where it's shared with me. And then so I take this notebook, and then I have to essentially I go through all of this, and then I'm like, well, this is amazing, but I have to engineer parts of it to understand it for myself, right? And then so I start off backing up a little bit. So I just build a model, right? Just build a neural network. And then so my test is like that. I figure I shouldn't have to use a DeepSeek model. I can just use like a CNN classifier model, etc. And then so that's what I do, right? And so I just build out a CNN classifier, fashion MNIST, very straightforward test. And then I do essentially I just find superweights and then just broadly prune across the board, right? Like if it's a superweight, cut it out. What happens? And we can see like it's moderate impact, right? Like there's an impact, so something happens here, but like it's moderate. And then so I'm like, okay, so I can see that there is an impact. So next step that I want to do is my hypothesis at this point is that these are tied, that the superweights, that there's a correlation between these superweights and entropy. I think that perhaps these superweights have more entropy, like an excess amount of entropy. And then so that's what I do here in this experiment. And then that experiment turns out wrong. That like it's not necessarily entropy, right? So I find these superweights, I prune them out, and then I measure entropy, and entropy stays the same. So it's like, okay, that's not the lever. That's not the specific lever. I thought that would be the lever, but it's not. So next thing I go through is let me go through and train on train these superweights, and then find these superweights and then classify them individually. And then rather than just popping like all of the superweights at once, let me pop individual ones, and then let me see the entropy of the individual superweights, right? And then so that's what I do here, and then that paints a completely different picture. And so what this picture shows me is that like my original assumption was accurate, that there is entropy at play here, right? It's just maybe it all balanced out evenly within my first test by going through and just removing all of them, because there would all be all combined would possibly be even representation of the data set overall, possibly, you know. So, but what we can see here is that within these individual ones, like some of them, like there's this one, if I obliterate it, then entropy like is huge loss of entropy. If I prune another one, there's a slight increase in entropy, and then if I prune a third one, there's a slight decrease in entropy. So like 3 different behaviors by pruning these 3 different weights, we get 3 very different entropy outcomes, right? And then so to me, that's good. Like, okay, cool. Now I have something to classify off of. I don't know how to classify this, but I know it does know how to classify this, a classifier AI. And then so that's what I built. I built a decision tree classifier, and then I just train it on this, right? And then so I have it go through. And then I essentially create categories. So good, bad, and neutral. And I want to isolate out of these superweights. So now that I can isolate a superweight, and it's relatively easy to isolate a superweight given all of this, I'll share all of the paper, both of these collabs. It's really easy to put all of this together once you understand it and how to isolate these superweights. Isolating them is super easy. Categorizing them is now super easy. I can categorize them into bad, good, or neutral. And then I can do this with very high accuracy at this. So this is very low accuracy at this point, right? Because I'm missing data sets within the neutral category. And then so what I do with this model is I train, so this is my CNN model trained on the fashion MNIST data set. And then this last code block here, this could be modified for any model. Right, so this last code block is the superweight detector and classifier, and all this is doing is just essentially taking my data set, which is fashion MNIST in this instance, and it's just pooping out the superweights out of give me the top 200 300 superweights out of this data set, and then that's what I have here, right? So I have I think it's this one. I could have told you in a second. Superweight dataset fix, this one. Cool. So I have 294 entries in this data set at this point. And then so I will also upload this full data set to my Hugging Face. My hope is like, if you want to pick up this project, do this. This data set is amazing. We need more of this, right? So I'm giving you 300 rows to start. Here's the world, 300 rows. And then essentially it's broken up into these classes, right? So bad, good, and neutral. And then you have all the metrics that you need with regards to the weights. It'll find them and tell you exactly where they are, what layer they're in, etc. And then you can just go through, and then once we have like my goal is to make this data set even bigger, right? The bigger we can make this data set, the better. And then so the more that this classifier goes up. So right now I can classify a bad weight with 85% accuracy, a good superweight with 75% accuracy, and a neutral superweight with 77% accuracy. Give me more data, these numbers go up. And then we can pull levers with this, right? So you want to improve model performance, like 20% with 3 weights, we could do that. You want to remove the worst to 5% of the model weights to increase performance, we can do that, right? Like, and we could do the opposite if you want to too. But so that's what this gives us access to, right? Is all of that. All we need at this point for this is more data, right? Like, here's the classifier, here's how it works. What the world is missing at this point with all of this is more data set. Like, this is a brand new concept. I mean, recently proven out, right? So it's here. You can do it. This is very cool. This methodology is amazing overall. If this strikes you, here's the collab. You want this, so you want to go to the superweight detector and classifier very specifically, and then this is if you're wanting to play around with making like my kind of operation that will essentially generate file for you, and then so this is going to get you like as many will pop out of that particular file and that data set. If you can increase it to more super weights, right? And then you can utilize this with bigger models if you want, whatever model you want to plug this into and adjust this for. This is all an open source license. Feel free to go add it. And then same thing with the original notebook that was shared with me, right? The only difference is with this one is like this one. So I mean, this one, if you want this type of in-depth, beautiful information, then this is the way to go, right? Mine is I want this CSV file. Like this is what is going to be, I think, the most valuable for the world at the end of the day, right? And so again, I'll upload this CSV file to Hugging Face, and I'll have it here and ready for anyone to look at and utilize this data as well as these collab notebooks. If you like this type of content, please like and subscribe. Thank you very much.